Hey guys, this is Chemplified and in this video we will talk about NERNST equation. Let's start. This is our NERNST equation. All these terms and their notations are given below. You can read them. E cell represents electrode potential at any temperature and concentration. E naught cell represents electrode potential at 1 atmospheric pressure 25 degrees Celsius and concentration should be 1 molar. R is gas constant, T is temperature, F is Faraday's constant whose value is about 96500 coulomb. P and R represents the concentration of products and reactant. N is important because it represents the number of electron lost or number of electrons gained or number of electrons transferred. It does not mean, N does not mean here moles. In this case, N is not equal to number of moles, right? Remember this particular thing. Now, this is our original NERNST equation. In place of this equation, we can also use the short form of NERNST equation, which is this one. In this equation, we have used the value 0.059. Now, from where this particular value came, let's take a look at that. In the previous equation or the original equation, you can see that 2.303 is a constant value. R is a constant, temperature is a constant if we are taking 298 Kelvin, right? And Faraday is, F is also a constant, F has a constant value. When you multiply all these terms and divide all these terms, you will get a particular value which is equal to 0.059, approximately 0.059, right? So we are using this value in place of 2.303 RT by NF. Now, understood? I hope you understood how we reached this particular conclusion. Now let's go for the derivation, right? We will derive our NERNST equation from thermochemistry. So before we do that, we should know a simple term, delta G. What is the meaning of delta G? Delta G is change in Gibbs free energy. Right? And delta G is equal to negative of useful work done. Now, since we are talking about, or since we are dealing with electrochemical cell, the work done in this particular case will be electrical work done. So we can write delta G is equal to negative of work done electrical, right? Delta G is equal to negative of electrical work done. Now, electrical work is given by the formula W is equal to Q delta V, where Q is charge and delta V is potential difference. Now, in our case, the potential which we are talking about is electrode potential. So in place of delta V, you can write E cell or E naught cell. According to the case, we will take a look at these both values later. Just remember, delta V in our case is equal to E cell or E naught cell. Let's talk about Q. Q is our charge, right? Charge on electron, because we are talking about electron transfer. So we can write Q is equal to charge on one electron multiplied by number of electrons, right? Now charge on one electron is 1.67 multiplied by 10 to the power minus 19 coulomb. Number of electron depends upon the atom which we are using. For example, let us suppose we are using zinc. Now zinc, when undergo oxidation, it gives Zn2 plus 2 electron, right? Now if we consider the number of moles, then 1 mole of zinc gives 1 mole Zn2 plus, but number of electrons given by 1 mole zinc is 2 mole, right? So number of electron depends upon the type of atom which we are using, and N represents the number of moles. So we can write N multiplied by Avogadro number, that is 6.022 into 10 to the power 23. N represents number of moles of electron. Since one atom is releasing 2 electron, 1 mole zinc will release 2 mole of electron. So in case of zinc, we will write the value of N is equal to 2. So the final formula, for the final formula, what you have to do is you have to multiply this value, the charge on one electron, multiplied by Avogadro number, and when you do that, you find that Q is equal to N multiplied by 96485 coulomb. Wait a second. Now this value is approximately equal to 96500 coulomb, and charge is equal to NF, right? We have reached our conclusion that Q is equal to NF. Now according to our formula, delta G is work done is equal to Q delta V. We already know that delta V is equal to E cell, and Q is equal to NF. So for our final formula, we can write work done is equal to NF E cell, right? Now delta G is equal to negative of work done electrical. Now work done value is NF E cell. Just substitute the value and you will get delta G is equal to minus NF E cell. Now for standard Gibbs free energy, you can write delta G naught is equal to minus NF E naught cell. Here is your E cell and here is your E naught cell, right? Now from thermochemistry, we have our equation delta G is equal to delta G naught plus 2.303 RT log Q, right? Now in place of delta G, write minus NF E cell. In place of delta G naught, write minus NF E naught cell. So just substitute the values. Minus NF E cell is equal to minus NF E naught cell plus 2.303 RT log Q. Now divide the whole equation by minus NF. I repeat, divide the whole equation by minus NF and minus NF. NF will be cancelled, negative sign will be cancelled, NF will be cancelled, negative sign will be cancelled, and you will get the equation as E cell is equal to E naught cell. In this case, negative sign will take the position of positive charge, and you can write minus 2.303 RT by NF log Q. Q is your reaction quotient. In place of Q, if you write the value of product and reactants, you can write the equation as E cell is equal to E naught cell minus 2.303 RT by NF log product upon reactant. This is your NERNST equation. I hope you understood. If you want to change the values, you can multiply all these terms and divide it by F. You will get E cell is equal to E naught cell minus 0.059 upon N log P by R. This is your final NERNST equation. This was your NERNST equation. Let's take a look at few examples. We will not solve it, but we will try to understand the use of NERNST equation and how to put the values. Now in this question, there is one equation given. This is your equation. Pb2 plus Cd gives Pb plus Cd2 plus, and E naught cell value is already given, right? Temperature is also given 25 degree, which is equal to 298 Kelvin. Why I am writing this? Let's take a look at the answer. First you have to write the NERNST equation. E cell is equal to E naught cell. Wait a second. E cell is equal to E naught cell minus 2.303 RT by NF log product concentration upon reactant concentration. Now the equation is already given. CD2 plus in product is in product and Pb2 plus is in reactant. The value of N is equal to 2. N is equal to 2. Why? Because there are two electrons which are getting transferred from Pb to from CD to Pb2 plus, right? Now we can change this equation from 2.303 RT to 0.059. Write it down as E naught cell minus 0.059 upon N log product upon reactant. Now this 0.059 is kind of difficult to divide by any number, so you can approximately take it equal to 0.06. This will make your numerical problem easy, a little bit easy. So in place of 0.059 you can write 0.06 and remove the 9. Now substitute the values. E naught cell value is given, that is 0.277 minus 0.06 upon N is equal to 2 log product value is cadmium is in product, so you can write down 0.02 upon 0.2, right? After this, all which is left is mathematics. Just solve the numerical and reach the answer. Let's take a look at the next numerical. Look at the second question. In this particular question, what they have given is, they have provided you with the concentration of the ions. They have not given the cell reaction, so you have to write the cell reaction on your own. Now, and apart from that, they have provided you with the standard reduction potential of nickel and aluminum. So you have to decide which one will undergo oxidation, which one will undergo reduction. We know that the one with lower value will undergo oxidation. So we can say that aluminum is undergoing oxidation in the cell reaction. You will write aluminum gives Al3 plus 3 electron, right? For nickel you have to write Ni2 plus 2 electron gives Ni. Now in this case the number of electrons are different, so what you have to do is you have to multiply this complete equation by 2 and this complete equation by 3. So the final equation which you are going to get is 2Al gives 2Al3 plus 6 electron and 3Ni 2 plus 6 electron gives 3Ni. Now write down the equation, cancel the electrons, and the final equation that you are going to get is 2Al plus 3Ni2 plus gives 2Al3 plus 3Ni. This will be your final equation. Now what you are going to do is you are going to write down the NERNST equation. Obviously NERNST equation is E cell is equal to E naught cell minus 0.059 by N log product upon reactant. In place of product you will write the value of Al3 plus, in place of reactant you will write down the value of Ni2 plus. Now in this particular equation you have to find E cell, right? You are also given with the value of N which is equal to 6, because there is transfer of 6 electrons. You have the concentration of aluminum, you have the concentration of nickel. The only thing that you don't have is E naught cell. You have to find the standard electrode potential value from the values given, the given values. E naught cell is equal to E naught cathode minus E naught anode, right? Now at anode oxidation take place and aluminium is undergoing oxidation, so at anode you will write the value of aluminium and at cathode you will write the value of nickel. So write down the values. You will get minus 0.25 minus 1.66, and when you solve it you will get the value 1.41 volt. So the value of E naught cell is 1.41 L. Substitute all these values in the equation. After substituting you will get 1.41 minus 0.0591, or approximately you can write 0.06 upon 6 log. Now in place of product you have to write the concentration of aluminium, and the concentration of aluminium is 10 to the power minus 3 upon 5 into 10 to the power minus 1. Now in the power you have to write 2 in case of aluminium and 3 in case of nickel. Why we are doing it? Let's take a look. In the cell reaction, if you look, you get that nickel has a coefficient of 3 and aluminium has a coefficient of 2. So wherever you write the concentration of aluminium, you raise it to the power of 2, and wherever you write the value of nickel, you raise it to the power of 3. Alright. Now in the equation the values given is 0.001, which is approximately equal to 10 to the power minus 3, and this 0.5 you can write it as 5 into 10 to the power minus 1, right? Now in the similar way as previous question, after this point what remains is mathematics. Just solve the equation and reach the final answer. The final answer is approximately equal to 1.415 volt. So this will be your final answer. I hope you understood how to solve it. This will be it for today's video. Thank you very much for watching. Have a good day. Before we end the video, let me tell you the answer of the first question also. The approximate answer for this question number 1 is equal to, approximate answer is 0.306 volt. Alright, so this will be your approximate answer for this question number 1. I hope you are able to understand today's concept. Thank you very much for watching.